From the moment the first telescope pointed toward the night sky, humanity has looked outward, chasing the mysteries of distant worlds. Yet, as we stand on the shore of an ocean that covers more than 70% of our planet, we admit that the deepest trenches remain largely unseen. In a paradox that feels almost cinematic, the barren plains of Mars have been charted, photographed, and sampled more thoroughly than the abyssal depths of our own seas. The story begins in the 1960s, when the space race ignited a global obsession with the red planet. Soviet probes like Mars 2 and 3, and later NASA's Mariner series, delivered the first blurry images of a world that seemed both alien and eerily familiar. Simultaneously, oceanographers were still relying on echoes sounding from surface vessels, a technology that could only scratch the surface of the seafloor's vast, uncharted expanses. Why did Mars receive such an outsized share of scientific and public attention? One answer lies in the economics of ambition. A single interplanetary mission, though costly, consolidates its budget into a clear, headline-grabbing objective: landing a rover, returning samples, searching for life. By contrast, deep-sea exploration demands a fleet of specialized vessels, submersibles, and long-term funding streams that rarely capture the imagination in the same way. Technological breakthroughs also tipped the scales. The development of high-resolution orbital cameras, laser altimeters, and autonomous rovers created a feedback loop. More data spurred more missions, which in turn produced ever-sharper images. In the ocean, the opacity of water limits visual range, and the pressure at depth renders many instruments fragile and short-lived, slowing the pace of discovery. Political narratives amplified the disparity. The United States framed the moon landing as a victory over a rival, and Mars quickly inherited that mantle as the next frontier of geopolitical prestige. Nations invest in space because the achievement can be displayed on a global stage, emblazoned on flags and stamps. The ocean, despite its strategic importance for resources and climate, rarely offers the same symbolic payoff. Scientific curiosity, however, is not the sole driver. The promise of discovering past or present life on Mars fuels a narrative that resonates with humanity's deepest questions. The ancient river valleys, the polar ice caps, the recurring dust storms, all suggest a planet that once may have been habitable. The ocean, while teeming with life, lacks that tantalizing mystery of what if we are not alone. Funding agencies reflect these priorities. NASA's budget allocations show a steady increase for Mars science, especially after the success of the Curiosity rover and the Perseverance mission. Meanwhile, the National Oceanic and Atmospheric Administration's deep-sea programs have faced periodic cuts, leaving large swaths of the seafloor mapped only by low-resolution satellite altimetry. The human element cannot be ignored. Astronauts and engineers are drawn to the romance of stepping onto another world. The image of a boot imprint on Martian dust is iconic, while the image of a submersible illuminated by a single beam of light in the abyss is less marketable. Media outlets, documentaries, and popular culture have amplified the former, creating a feedback loop of interest and investment. Yet the ocean remains a frontier of unparalleled scientific value. Its role in carbon sequestration, climate regulation, and biodiversity is critical to Earth's future. The discovery of hydrothermal vents in the 1970s revealed ecosystems that thrive without sunlight, reshaping our understanding of life's adaptability. These insights, however, are confined to a fraction of the ocean floor, leaving the majority of the abyss unexplored. Recent advances hint at a possible shift. Autonomous underwater vehicles, equipped with AI navigation, can now map kilometers of seafloor without direct human control. Simultaneously, satellite gravimetry provides indirect clues about underwater topography. These tools promise a renaissance in marine exploration, potentially narrowing the gap with planetary missions. International collaboration also mirrors space endeavors. The European Space Agency, Roscosmos, and China's CNSA have all launched missions to Mars, sharing data in unprecedented ways. In the marine realm, initiatives like the Global Ocean Observing System aim to pool resources across nations, but geopolitical tensions over maritime boundaries often hinder unified effort. Public perception plays a decisive role. Surveys consistently show higher excitement for Mars missions than for deep-sea expeditions. The allure of alien landscapes, the prospect of finding fossils of ancient microbes, and the cinematic potential of red dust storms capture imaginations more readily than the muted, alien world of the deep ocean, despite its biological richness. Education systems reinforce this divide. Curriculum standards allocate more time to astronomy and planetary science than to oceanography. Young students are more likely to see a poster of a rocket than a diagram of a continental slope. This early exposure shapes career aspirations, feeding a pipeline of scientists dedicated to the stars rather than the seas. Economic incentives further skew investment. The prospect of mining asteroids or extracting water from Martian ice for fuel presents a clear commercial narrative. In contrast, the ocean's mineral wealth, such as polymetallic nodules, is entangled in environmental concerns and regulatory uncertainty, dampening private sector enthusiasm. As we look ahead, the balance may tip. The next decade promises crewed missions to Mars, but also ambitious projects like the Ocean Exploration Trust's 5-year seafloor census. The choice is not binary, rather, it reflects how humanity values visible milestones versus hidden, essential processes. The oceans sustain us, yet the red planet beckons as the next symbol of progress. In the final analysis, the disparity between Mars and ocean exploration is a mirror of our priorities, our fears, and our dreams. It reveals a species eager to look outward for answers, while often overlooking the depths that lie beneath its own feet. The challenge now is to harmonize these quests, ensuring that the quest for extraterrestrial knowledge does not eclipse the imperative to understand and protect the world that already sustains us. Beneath the glittering veneer of satellite imagery, a quieter revolution is unfolding in the world's oceans. Autonomous underwater gliders, equipped with AI-driven sonar, now map seafloor topography in real time, revealing hidden volcanic ridges and ancient river channels. Yet, despite these breakthroughs, funding for such projects lags behind the budgets allocated to Martian rover missions, highlighting a disparity in where we choose to invest our curiosity. Consider the story of the Mariana Trench, the deepest known point on Earth. Recent expeditions have uncovered microbial ecosystems that thrive in complete darkness, feeding on chemical energy rather than sunlight. These discoveries could reshape our understanding of life's resilience, a knowledge that directly informs the search for life on Mars, yet the expedition costs are dwarfed by the price tag of a single Mars rover launch. The allure of Mars also fuels a booming private sector, where billionaire ventures promise rapid colonization timelines. In contrast, the oceanic sector remains fragmented, with research vessels often relying on aging infrastructure. This imbalance not only skews public perception but also delays critical advancements in climate modeling, which depend on precise oceanic data to predict future sea level rise. Educational outreach mirrors this trend. Children across the globe can watch live streams of the Perseverance rover digging for ancient rocks, while fewer schools have access to real-time footage from submersibles exploring coral reefs. When curiosity is fed by spectacular visuals from space, the quieter drama beneath the waves risks being relegated to textbooks rather than lived experience. Policy decisions further entrench the divide. International treaties governing the high seas prioritize navigation and resource extraction, whereas the Outer Space Treaty encourages scientific collaboration and peaceful exploration. Without a comparable framework for the deep ocean, nations lack a unified agenda to protect and study these hidden frontiers, leaving them vulnerable to exploitation. Finally, the cultural narrative of the final frontier shapes public imagination. Mars is portrayed as the next chapter of human destiny, a place to plant flags and build habitats. The ocean, however, is often cast as a hostile abyss to be conquered. Reframing the deep sea as a frontier of equal wonder could inspire a new generation of explorers who dive as eagerly as they launch, balancing our gaze between the stars and the seas.